Hello, my name is Keshwani. There's Keshwani, Keshwani. We are here because we want to prepare for the GRE. We have been solving GRE math problems out of this book here, the official guide to the revised GRE. If you do not own this book already, purchase one immediately. You're going to need it. The problems that we are about to solve are the ones that you will find on page number 261. Please turn to it. Page number 261, and today is our lesson number 372. We have two problems there, problem number 12 and 13, both dealing with circles. Let's take a look at 12. Number 12, these are straightforward problems. We have a circle here with a center O, we are told. Right here is the center, and here is the slice we are given here, which we are told is 40 degrees. And there is the arc A, B, C. A, B, C is the arc, the center is O, and we are told that the radius we are told is 4. So the radius is 4. The very first question they ask us is the circumference. Again, as I said, these are straightforward questions. Very simple questions. These questions will appear in the exam as easy questions. These are not even medium. Do you understand? The very first question ask us is for the circumference. But you do have to know your formulas. Do you understand? Circumference, we know, equals to 2 times pi times r, 2 times pi times r, which we are told is 4. So it's 2 times 4, which is 8 pi. Circumference equals 8 pi. Part B. The length of the arc ABC. Length of the arc ABC. Now, there are two ways actually you can say arc ABC. They actually spelled it out, but they didn't have to. Another way one conveys the notion of an arc is like this. Instead of saying arc ABC, they could have said ABC with a little, it's not a straight line, it's like that's an indication of an arc. In which case you don't even have to say ABC, you could just say arc AC, which would encompass B. The length of arc ABC. Let's set it up as a proportion, shall we? Let's set it up as a proportion. Let's set it up as a proportion problem. So here we have the length and here we have the degrees. And when we go through the 360 degrees, what we have is a circumference, the length that we're going to deal with if we go through the entire 360 degrees. If we start with A and if we go through the entire 360 degrees, what we're dealing with is a circumference, which we know is 8 pi. And the question is, how much is the distance if we go only 40 degrees? How much is that distance? There's not really much to do here if we are quick enough, if you're quick enough to recognize that 40 is 1/9 of 360. 4 times 9, 4 9s are 36. So the circumference, the length of this guy is going to be 1/9 of this quantity. What is 1/9 of 8 pi? Well, 1/9 of 8 pi is 8 pi over 9. That's all. That's what we're going to find here. Let's do it up here, shall we? So we are looking at this thing here. If we cross multiply, we find that 360 times x. 360 times x equals 8 pi over 8 pi times 40, and therefore x equals to 8 pi times 40 over 360. Let's divide top and bottom by 10. If we divide top and bottom by 10, we can cross out the 4s, we can knock out the zeros. Let's divide top and bottom by 4. How many 4s in the 36? We just talked about it a second ago. 36 has 9 4s. So this 4 goes away and we end up with 9. That's just like we said, just like we knew it was going to happen. The length of this guy is 1/9 of the circumference. Why is it 1/9? Because 40 is 1/9 of 360. That's all. As you can see, 8 pi over 9. The arc that we're looking for is 8 pi over 9, which is the arc ABC. Whatever the circumference was, it's going to be 1/9 of that. Let's move on then. Part C. In part C, they're looking for the area of the slice here. The area of this slice right here. What's going to be the area of this slice? Let's find out, shall we? Let's erase this outside part, it's annoying. Again, the area is also going to be the 9th of the whole circle, because that's what that slice represents, the 9th of the circle. So the area we know, area of the slice is going to be 2 pi r, which is not 2 pi r. This is not, we're talking about area, not the length of the arc, which we already did that. We're talking about the area, which is pi r squared, and it's going to be 9th of that. And pi r squared, r we know is 4. So it's 4 squared over 9, or 16 over 9 pi. 16 over 9 pi. Whatever the area of the circle is the 9th of that. That's all. Let's go on then, shall we? Let's do the next problem. The last problem on the page there. Just give me 1 second. But in order for us to be able to realize that this is the area, we do have to make the connection right away that the slice that we're looking at is the 9th of the circle. We have to make the connection in order to find out the length of this arc, because length of this arc is the 9th of the circumference, and the area of this slice is 9th of the circle, because 40 degrees represents 9th of 360. Do you understand? The last problem that you see here on the page, number 13. We are given two concentric circles with center O. Concentric is just a simply way of saying that they share the center, they have the same center. So here's a smaller circle here, and here's a larger circle, and they both share the center O. We are further told that the radius of the large one, we are told, is 12. We are told that the radius of the small one, we are told, is 7. Small circle has a radius of 7. The large one has a radius of 12. In other words, from here to here is 7. And how much is it from here to here? Instead of going here to here, let's give them name here. So this is O, let's call this point A and point B. So the area of the small circle is 7, which means O to A is 7. How much is A to B is what I'm asking you. How much is A to B? A to B is 5. A to B is not 7. A to B is not 12. A to B is 5, because the radius of the large one is from here all the way to here, which is 7 plus 5. This one is not drawn to scale, as you already know. As I always remind you, no pictures on the GRE are drawn to scale unless they tell you that it's drawn to scale. This clearly is not drawn to scale, because I'm showing you a shorter line and I'm claiming that that's 9 units long, and this longer line we're claiming it is 5 units long, which is okay. It's alright. Pictures are not drawn to scale. So 12, which represents OA plus AB. Anyway, that's what's irrelevant. Nobody's asking us for any of that. The very first thing they ask us is the circumference. The circumference of the large one. Circumference of the large one is going to be 2 pi r, which is 2 times pi times the radius of the large one, which we know is 12. 2 times 12 is 24 pi. 24 pi 24 pi. Part B. In the part B, they're looking for the area of the small circle. Area of the small circle, let's do it up here. Area of the small circle, which is going to be pi r squared, the radius of the small circle. Pi, and radius of the small circle is 7. So it's 7 squared, which gives us 49 pi. So that was part B. Let's move on then. And in part C, they're looking for the area of the shaded region. The area of the shaded region is this guy right here. They're looking for the area of the ring. Let's find out the area of the ring, shall we? In order for us to be able to find out the area of this ring here that they're talking about, we have to know the area of the small circle and we have to know the area of the large circle. And what we're going to do is, we're going to take the area of the large circle, and from the area of the large circle, we're going to subtract the area of the small circle. And that's going to give us the area of the ring. Area of the ring which they're calling the shaded portion, equals the area of the large circle minus the area of the small circle. But we already know the area of the small circle. The area of the small circle is right here. We have to find out the area of the large circle. Let's find out, shall we? Area of the large circle is equal to pi r squared, the radius of the large circle. The subscript L stands for the fact that it's large circle that we're dealing with. Pi r squared, pi times the radius of the large circle is 12, 7 plus 5. 12 squared. Of course, 12 squared is 144. 144 pi. That's the area of the large circle. And therefore, the area of the ring that they're talking about is simply 144 minus 49. Let's find out what that is. 144 minus 49. 14 minus 9 would be 5. And this guy becomes 13. And 13 minus 4 is 95. So the area of the ring that they're talking about turns out to be 95 pi. It's 95 pi. And that was it. So like I said, these are not going to come up in the exam as not even medium questions. They're definitely, most certainly not going to come up as the hard questions. What will come up on the exam as a hard problem is the one that you see on the very next page. Let's turn the page. The problem that you see there on page number 262, number 14, that if you see on your exam, if you happen to see a question of that caliber on your exam, that is in fact a very good sign. Because only those people who are going to get a higher score, 70th percentile or above, see these kind of questions, the hard questions. If somebody is going to score below 70th percentile, they don't see hard questions. The easy and medium is all what they deal with. Do you understand? So if you see a hard question in the exam, don't be disheartened, don't be discouraged. That is actually a very good sign. Do you understand? Because it is computer adaptive. I'm done with my sermon. Amen. I'll see you tomorrow, okay? Bye now.